In this video, we're going to take a look at how to solve two problems on molarity. Let's take a look at the first one, which is it's asking you to calculate the molarity of a solution made by adding 45.4 grams of NaNO3 to a flask, and it's dissolved in water to create a total volume of 2.50 liters. So first and foremost, to solve for the molarity, we need to know that molarity M is equal to number of moles N over the volume. Okay, it's important to know that's the moles, and that is the volume in liters. Okay, so the volume is already given to us in liters out here. Moles is not given to us. So the first thing we need to do is convert these grams given to us into moles. And to do that, we need to know that to convert grams to moles, you need to divide the grams by the molar mass. Okay, so if you go ahead and calculate the molar mass of NaNO3, you will get 85.00 grams per mole. Okay, so let's go ahead and convert the grams to moles by dividing the grams given to us by the molar mass. So grams given to us is 45.4 grams. We'll divide that by 85.00 grams per mole, and that gives us 0.5341 moles. All right. Okay, so now we have the moles. So we know this, and then we know the volume. So now we just calculate the molarity by plugging into this expression or this equation. So 0.5341 moles is on top, and below we have 2.50 liters. And we divide both of them, you get 0.2136 molar. Now you're going to correct for significant figures. Out here, we're given three significant figures in the problem, so we're going to round that to 0.214 molar. Now, key thing to remember is molar can be expressed as a capital M, or it can be written as moles over MOL over capital L. Same thing. Okay. Okay. Let's take a look at the next problem. In the next problem, we're asked for the mass of KBr in grams, and they've given us the volume, which is 250.0 ml, and then they've given us the molarity. Okay. Now the key thing to remember is, in order to use this equation, we need the volume in liters. Okay, so the first thing we need to do is, first of all, try to understand how to use that equation. So the thought process is, if we have this equation, M is equal to N over V, molarity is given to us, and volume is given to us. Let's not worry about converting that to liters yet. Let's just think through this. So that means if we know this and this, we can solve for N. Okay, so solving this, we'll get N. Okay, but the question is not asking us for N, the number of moles. The question is asking us for what is the mass, which means we need to know how to go from moles to mass in grams. And to do that, you just need to multiply with the molar mass, okay? Which means that you have to find the molar mass of KBr. So let's go ahead and find that out. The molar mass of KBr is 119.00 grams over mole. Now, if we multiply the moles given to us, which we haven't found out yet, so let's go ahead and solve for that using this equation. So molarity is 1.50 molar. Let's go ahead and write the units for molar. So moles over liters. And number of moles we're solving for, so we keep that as N. Let's just use a different color out here since I was doing it in black. All right, so there you have it. Now, the volume, we cannot just use the 250.0 ml. We need to convert that to liters. So let's go ahead and convert that out here, 250.0 ml. To convert that into liters, we have to use the milliliter to liter conversion factor. So times 1 liter over 1000 ml. Okay, and when we do that, we should get 0.2500 liters. Let's go ahead and plug that in out here. That's going to be 0.2500 liters. And then if we solve for this, we get N is equal to 0.375 moles. Okay, now that's N. Now we can use this relationship, moles times the molar mass, to give us the mass, which is what the problem is asking us for. So we're going to take this number, 0.375 moles, and we'll multiply it with the molar mass, which we calculated, 119.00, and that is going to give us 44.625 grams. Now we correct for significant figures. We need to stop at this place, so that is equal to 44.6 grams of KBR.